Example 3 looks at an introduction to no solution inequalities, and sometimes we will write the abbreviation or acronym DNE, which stands for does not exist. This happens when there is an and compound inequality where the two intervals never overlap. Let us revisit the trucker example above, but let's change the direction the trucks travel. So two truck drivers are en route to their given destinations. Truck driver 1 leaves Moses Lake, Washington at Interstate 90, milepost 166, heading towards Seattle. Truck driver 2 leaves Spokane, Washington at mile 270 and drives toward Montana. How many miles of overlap on I-90 will the two truckers share or overlap? So here is 166. This is Moses Lake. Here's 270. That is Spokane. And truck driver 1 is heading towards Seattle. So in purple, I will start there and then shade to the left. And in red, I will start with a closed dot on Spokane, and they are traveling east towards Montana. So that's the west direction. This is the east direction. Now notice there's no area where both the purple and the red color are overlapping. So when it says write the given interval in interval notation, we're basically asking where do those two intervals overlap? And the way that we would want to write the intersection is we have the two intervals negative infinity to 166 bracket, and then the other interval is 270 off to infinity. And remember that the union symbol looked like a capital U. If we flip that upside down, the intersection symbol looks like an upside down capital U. And this is the intersection symbol. And that basically means that it wants us to figure out where the overlap is between these two intervals. And you can write this in a couple of different ways. You could say that it does not exist. So that's one possible way to write it. Or you could say, this is a symbol that's used by mathematicians. It's a circle with a diagonal slash through it. And this is what we call the empty set. So that's another possibility, is putting that circle with the diagonal slash through it to denote the empty set. The next part says, how might you connect this idea of inequalities to something in your life? Take a few moments to write a compound inequality statement. So go ahead and pause the video and take a moment to do that. So in this next part of the video, we're going to be solving some basic and compound inequalities. Example 4 wants us to solve the inequality negative 15 is less than 5 times the quantity x minus 4, which is less than or equal to 30. Then we want to state our answer in interval notation. So the first thing that we want to do, looking at this, is since the 5 is factored out in the middle, we're trying to get it so that the thing in the middle is just our variable x. And so what we want to do first is we want to divide all components of our inequality by 5. And if we do that, this 5 will divide with that and leave us with 1. And then on the left-hand side, we would be left with negative 15 over 5, which is negative 3, is less than x minus 4, which is less than 30 divided by 5, which is 6. So now we almost have our variable by itself, but now we want to add 4 on all parts of our compound inequality. So if we do that, negative 3 plus 4 is 1. In the middle, we're just left with x. and then less than or equal to 6 plus 4 is 10. So if we're talking about inequality notation, then our answer would be 1 is less than x, which is less than or equal to 10. And then if we're talking about interval notation, we would write parenthesis 1 comma 10 bracket. So that is how we do example 4. All right, example 5 wants us to solve the inequality 2 times the quantity x plus 2 is less than or equal to negative 9 minus x. Now notice this one is not a compound inequality. There's only one inequality symbol. So we want to get everything that has a variable on one side of the equation and everything that does not have a variable on the other side of the, I think I said equation earlier. I meant to say inequality, not equation. So the first thing that we want to do is we want to distribute the 2 into both of these terms so that we can get everything on one side with a variable and everything that doesn't have a variable on the other side. So if I distribute, then we get 2x plus 4 is less than or equal to negative 9 minus x. Now I can start moving stuff to the other side. So I'm going to add x to both sides. And if I do that, we get 3x plus 4 is less than or equal to negative 9. And then I'm going to subtract 4 on both sides. And we get 3x is less than or equal to negative 13. And then I want to divide both sides by 3. And don't forget, whenever you divide or multiply by a negative number, we have to switch the direction of the inequality symbol. But notice that we are not dealing with negatives here, so we don't have to worry about that in this scenario. So we have x is less than or equal to negative 13 over 3. So that would be our answer in inequality notation. And for interval, we would have negative infinity to negative 13 over 3 with a bracket like that. So that is the answer for example 5. Okay, example 6 wants us to solve the compound inequality negative 8 is less than or equal to 13x plus 7 is less than or equal to negative 4. So the first thing that I want to do is I want to subtract 7 from all parts of the inequality. And if I do that, we get negative 15 is less than or equal to 13x is less than or equal to negative 11. And then from here, we want to divide everything by 13. So we'll get negative 15 over 13 is less than or equal to x, which is less than or equal to negative 11 over 13. So this is our final answer in inequality notation. And then in interval notation, that would look like negative 15 over 13 with a bracket, comma, negative 11 over 13, also with a bracket. So that is in interval notation, and this is in inequality notation.